Hey, so as an architect, you know the drill. Your job is to build systems that can handle just about anything. But what happens when anything turns into your app going from 100 users to 100,000 in a matter of minutes? That's what we're going to tackle. We're going to dive deep into mastering elastic compute on Google Cloud so you can handle any traffic spike, and I mean any, without even breaking a sweat.
So here's the plan. First, we're going to define the enemy, that unpredictable traffic problem we all face. Then, we'll meet the heroes of our story, GCP's Elastic Compute Trio. After that, the fun begins. We're going to simulate a massive traffic spike to see how they actually perform under pressure. Then, we'll get real about the cost of all this scaling. And finally, we'll wrap it all up with a solid playbook of design patterns you can use right away.
You know, it really doesn't matter if you're at a tiny startup or a huge enterprise. Every single architect fights the same battle. User traffic is just this wild, unpredictable beast. You need a system that doesn't just survive when things get crazy, but actually thrives on it.
Okay, so let me just ask you this straight up. Imagine that feature you just shipped suddenly goes viral. It's all over social media. The whole world is knocking on your app's front door, all at once. Is your infrastructure going to welcome them in, or is it going to crumble into a pile of 500 errors? That's the question, and that's exactly what we're here to prepare for.
The good news is we are not going into this fight empty-handed. Not at all. Google Cloud gives us a seriously powerful arsenal built for exactly this scenario. So let's meet the 3 core services that make up our Elastic Compute Toolkit.
So in our toolkit, we've got 3 amazing options. First up, for your more traditional apps, you've got Google Compute Engine, which is all about scaling your fleet of virtual machines. Then for the container-centric world, there's Google Kubernetes Engine, which scales the entire cluster your containers live on. And finally, for the I don't want to manage servers approach, there's Cloud Run, which scales your containers directly, almost like magic.
Okay, enough talk. Theory's great, but the only way to really understand these tools is to put them to the test. So that's what we're going to do. We're about to unleash a massive, sudden traffic surge. Let's watch how our GCP trio reacts in real time.
And here we go. This is the moment of truth. Maybe it's a viral tweet, maybe it's a huge marketing push. Honestly, the why doesn't matter. All that matters is that requests are pouring in and the system needs to respond like right now.
Just look at how fast this is happening. We're going from a totally normal 100 requests per second to 5,000 in just 2 minutes. By the 5-minute mark, we're getting hit with 20,000 requests every single second. This isn't a gentle ramp up, it's a vertical cliff, and our system has to scale it.
So first up is our app running on Google Compute Engine. Its main line of defense is the instance group autoscaler. And the idea here is really simple. When the load gets too heavy, it just adds more VMs to the group to help carry the weight.
So what's actually happening under the hood? Well, it's a pretty straightforward chain reaction. The load balancer starts getting slammed with traffic. That, in turn, pegs the CPU on our existing servers. The second that CPU usage crosses the threshold we've set, bam, the autoscaler wakes up and starts spinning up brand new VMs to join the party.
And here you can see it in action. It's working. It scales from our baseline of 2 VMs up to 6 and then all the way to 10 to handle the peak. Each new VM is another soldier in the fight, showing up just in time to keep the app online. It's a solid, reliable response. All right, now let's look at Kubernetes. The strategy here is a bit different. See, instead of just making more copies of our app, the GKE cluster autoscaler actually adds whole new servers, we call them nodes, to the cluster itself. It's basically expanding the foundation so that Kubernetes has more room to run everything. The way this gets triggered is actually pretty brilliant. Think of it like a restaurant. As more customers, that's our traffic, show up, Kubernetes tries to seat them at new tables, which are our application pods. But when every single table is full and there's a line out the door, that's a signal to the manager, the cluster autoscaler, to say, hey, we need to open up a whole new dining room. And it does that by adding more nodes. And the result is a cluster that literally grows to meet the moment. We see it go from 3 nodes to 8. Each one of those new nodes is like fresh real estate, giving Kubernetes all the space it needs to schedule the new app containers required to handle that insane 20,000 requests per second spike. And last but not least, we have Cloud Run, our serverless option. And its whole philosophy is just different. This isn't about scaling VMs or nodes. It's about scaling container instances directly, one-to-one with incoming requests. And, this is the kicker, it can scale all the way back down to 0 when the traffic dies down.
The reaction time here is on a whole other level. I mean, instead of waiting for a whole virtual machine to boot up, which can take minutes, Cloud Run just launches new container instances nearly instantaneously. The moment one instance gets busy, another one is already spinning up to take the next request. It's incredibly direct and incredibly fast.
I mean, just look at these numbers. It's wild. We go from just one lonely instance to 50 in 2 minutes. And at the peak of the spike, we're running 200 instances. This just perfectly shows that fine-grained, super fast, and frankly massive scalability you get with a serverless platform.
Okay, so deep breath. We survived the spike. That's awesome. But as architects, our job isn't just about survival, right? It's also about being smart, efficient, and cost-effective. Handling all that traffic came with some serious trade-offs, and understanding those is the real key to building a system that lasts.
And this leads us right to the heart of the architect's dilemma. It's a question we all have to answer. Do you over-provision? Pay for a bunch of extra capacity you don't always need just so you're ready for anything? That gives you great performance, but it can be really expensive. Or do you run lean to save a buck, but risk a slow, laggy experience when that traffic spike finally hits? It's that constant battle between cost and user experience.
Thankfully, we have some knobs we can turn to control this. The min instances setting is your best friend here. By setting it to something like 2 or 3, you're basically telling GCP, hey, always keep a few of these warm and ready to go. This dramatically cuts down that initial wait time. And on the flip side, max instances is your financial safety net. It's a hard ceiling that prevents a bug or an attack from scaling you into bankruptcy.
Now that delay we've been talking about, it has a name. It's called a cold start. It's basically the penalty you pay for the efficiency of scaling from zero. That very first request to a new instance has to wait for the whole thing to initialize. And that is exactly why the min instances setting is so powerful. It's your weapon to fight and eliminate that cold start for your users.
Okay, we've seen the problem, we've met the tools, and we've talked through the trade-offs. Now let's bring it all home and put it together into a simple, practical playbook. 4 essential patterns for designing systems that are not just scalable, but also safe, sane, and cost-effective.
All right, here are the 4 things you need to burn into your brain. 1. Baseline and burst. Use min instances for your day-to-day traffic. 2. Cost capping. I'm serious. Always set a max instance limit. It's your single most important safety feature. 3. Graceful degradation. Plan for the worst. What happens if you do hit your max limit? Does your app just fall over, or can it maybe serve a cache page or a friendly "we're busy" message? And 4, and this is the most important one, load test. Don't you dare wait for a real emergency. Create your own fire drill. Validate your configuration and find your breaking points before your users do.
Because at the end of the day, all of this stuff, min instances, max instances, CPU triggers, it's not just about technical settings in a console. These settings are your user's experience when your app is under pressure. So, is the story your system tells going to be one of seamless, flawless performance, or is it going to be a tragedy of lag and error pages? The choice, as the architect, is entirely yours.